Hey, what's up everyone? Welcome to the stream. Alright. So I did a little bit of work, mostly on my laptop. I pushed a couple of work in progress changes that I just wanted to pull in and mess around with. One of the things I noticed is that I should explicitly be setting this SDL GL set swap interval to 0. Otherwise, it seems like SDL looks like it wants to enable vsync. Which, I mean, is not inherently a bad thing, but I'd kind of like to at least control that option. Let's grab that, because I don't need to get. I tried a few different things. I tried setting the texture size to a power of 2, and that didn't really work super well. So I won't touch that. But this is something I wanted to look into. It's the filtering. Because one thing I noticed is I have this change in my emulator whereby I limit the maximal size of my texture to 1024 right now, and this was due to having some performance issues on my high DPI display. And then as a result, I noticed that on this monitor where I have a 1200 height, it just didn't look as great anymore. So I'll just show you what I mean. Say I maximize this. See, like, I was noticing, see if I can grab this. I was noticing that there are actually a lot of scaling artifacts in ever since I did this. You see like how there's just a lot of these kind of aliasing artifacts. And this has to do with nearest neighbor interpolation, which was not really an issue before when I wasn't clamping the size, but now of course there is scaling going on. Prior to this I would do no scaling, so nearest neighbor meant nothing would happen because there was no scaling at all, or barely any. But now we're upscaling. We're maximally at 1024, but this is a height of about 1200. And just to show the difference, if I change this to let's say 1200 or anything larger, suddenly it looks a lot better. And I just as a point of comparison, let's grab this here. I don't know if we'll be able to see it, but like, maybe it's not. I wish I could put them side by side, but unfortunately this, oh, you know what, I can. I know what I'll do. I'll do image canvas size. Let's go. Oops. Yeah, so here we can see the difference between the two. You know, here, due to nearest neighbor interpolation, we get like a bit more of like these, I don't know what you call them, but you can see the effect of the glow being sort of quantized, I guess is the word. Whereas here it's a bit more smooth. And this has to do with here being a linear interpolation, whereas here it's nearest neighbor. So just that on its own. Oh no, sorry. This has nothing to do with that. It has to do with the fact that in here we're not interpolating, and in here we are. Hey, Lisp Gamer. Good, how are you? So yeah, so I wanted to just do some tests with linear interpolation. Okay, and also I was thinking about my buffer formats and I wanted to change them. Because I mean, the 32F here, these 32F RGB buffers, I know I need them for my vector buffers because of the darken step that we take. I've done this before. If I don't do it, they never get to 0 because of the small time steps and the very small amounts that we reduce them by, especially based on delta time. If we have a really small amount of delta time, then the default the default size for RGB buffers, the values just like get quantized to 0 and we get no change in darkening effect. So these have to be 32F, but actually the rest here really doesn't. So this will actually be faster. And finally, the one buffer that we render to screen, in which case we I think it's this one here, the screen. I think this is the one that we need to worry about doing the GL linear on it. So I have like a filtering option here, yeah. Something like that. Let's see what this looks like. Maybe I shouldn't have closed my paint.net. Okay, so this definitely looks more filtered. I really shouldn't have Actually, you know what I'm going to do is I'm going to disable the overlay. Yeah, that looks pretty good actually. So this is okay, I'm just gonna put over here. I just want to recompare it to what I had earlier. And I'm going to put this like that. Wow, that looks pretty terrible. Should really do some layering here. Okay, and then finally, if we set the size here to something really big, just want to see if like we get something comparable. Well, it's definitely comparable. So here on the left we have linear interpolation. Here we have linear, but there's no interpolating going on. So this is kind of like the perfect case. And then here we have, this is the nearest neighbor, and then this is linear interpolation at the same resolution as this one here. So basically we can see that this one here is pretty good. It's close to our like ultimate version. Now I think ultimately I'll probably want to give like some control to the user, maybe a kind of like a quality control thing, because really, here I could totally not limit the texture size and it'll look great, But if you have a weaker system, limiting the texture size to let's say 1024, which will increase the frame rate. And still look pretty good, I think. Oh, well, not like this. If I can put back linear interpolation here. It definitely looks more blurry, that's for sure. But if I, boost this up, then it looks pretty much the same as before because there's no interpolating going on. You see already here, the frame rate is a little inconsistent. Again, that's because I'm streaming though. Okay, now we're back to decent frame rates. I don't know. I don't know what to do about this max texture size. I keep going back and forth on this. I think one thing that's cute is if you reduce the texture size, and like what it starts to look like, the game and the emulator here, just to show. Like normally, we're like this. And if I start reducing it and not die. I don't know why I think this is kind of fun. Maybe what I'll do is I'll put a like enable max texture size. And for now, I'll put it to false, but we can play with it if we want to have it set to true. All right, let's see how this goes. One thing I really need to do is I need to figure out, like, I mean, some of these options I'm just kind of messing with for myself when I'm developing, but some of these are really options that I want to provide to the user. Okay, here we can really see the difference, just toggling on and off. Not this one, sorry. It's this one. I'm not sure if it's obvious on stream because of the video quality and the side stuff. For me, it's pretty obvious. If I enable the max exercise, it becomes a lot more blurry because now it's interpolating the pixels up. Otherwise, it just looks more crisp. And in terms of frame rate, right now I've got 97, 77, 92. Now if I turn on the max texture size, I'm at 100. I gain about 20 FPS on this machine right now. Alright, I think I'm gonna commit it this way. I think I'm gonna do this in a few parts. I'm going to grab these here. I'm going to say use RGB32F buffers only for vector buffers. Regular RGB for the rest. Or I'm sorry, for vector textures. Format. Use RGB32F format only for vector textures. And regular RGB for the rest. And enable linear interpolation for final texture to back buffer. Here it'll say gender, enable max texture size, flag, false by default. It's weird how they decided to just use numbers for these. I guess we could add our own little enum here. No vtrace, or no vsync, I should say. And the last one is adaptive, is it? Yeah, I think they call this adaptive. I think we had noticed that when we turn on VSync here, we actually drop to 30 FPS on this machine for some reason. I'm gonna try it again, just curious. It's like right now we're hitting, let's say 140. Yeah, you see we're getting around 30 for some reason. It's really odd. What if this actually feels like 30? Let's say it doesn't really feel like 30. Actually, yeah, no, it kind of does. I can sort of see the slowdown. It's not super obvious though, to be fair. But I don't know why this happens. Adaptive, I think, doesn't do much. Actually, adaptive is the worst. For some reason, I'm hitting like 20 now. So here, set forcibly disable vsync. Okay. So I just want to take another render.capture. Hopefully I don't mess up my system this time. Hey, what's up, Meshu? I'm good, how are you? Thanks for dropping by. I'm happy to see that the frame rate here is very close to what I compute, actually. Sometimes it's a bit higher, sometimes a bit lower, because I guess it's averaging on its own clock. Very similar to mine. I wonder what this one means here. So that's the frame of this here, 3 point whatever dot dot 33. My streams are cool, but no one is watching. What are you gonna do? I'm glad you think so. Maybe it's because it's Monday. Yeah, so one thing I noticed really is that all of these screen space shaders that I have, like the darken texture pass, which I call twice because I do it for the normal vectors lines and the thick ones that I use for glow, and the glow pass, which actually does 2 different passes to apply glow, the horizontal and vertical, are extremely expensive relative to, like, obviously to drawing the vectors. And you can see it here. The draw vectors pass like takes like 16 microseconds. And you know, and then the darken texture pass takes 538, right? So yeah, quite a bit longer. Another draw vectors here for the thicker lines, and then another 539 for darkening. And then here for the glow pass, each one takes about 757, say 750. We just combine, and we have this render. And I actually got rid of one of the passes, which was a scaling pass, because I just do it now in the combine vectors and glow pass. But definitely there's some places I'm sure I could optimize here. I tried things, you know, I tried, like, actually one of the changes I made, but it didn't make much of a difference there. I don't think it made any difference, but I moved back the constants I had for applying glow. I had them as uniforms, and I just put them back in as constants because I actually never played with them. I had them as like tweakable values, and I thought maybe, you know, maybe if the fragment shader didn't have to read uniform values here, it could just, you know, optimize here, it would go faster. Mesh was asking, am I using matrices? You mean for doing the blur? I'm just doing it like this, you know, kind of straight up. I sample, but I have like, how many times? It's a 9-tap filter here with predefined Gaussian weights, as I wrote here. And I basically just do a horizontal pass and a vertical pass, so 2 separate passes. Like over here we have this like H step and V step, which are direction.x and direction.y times the blur factor or whatever. And then basically one pass x is 1 and y is 0, and the other pass y is 1 and x is 0. Right. So you're saying I could speed this up by doing like a matrix multiply? I suppose I could, right? Like make a vec4 at least of these 4 values. You see here? But I mean, I think, isn't the big part, yes, translation matrix, scale matrix. But I mean, I wonder, isn't the biggest part of the cost here just the sampling? I won't really get rid of the sampling. There's like nine places where I sample here, right? Like I feel if all I did was sample 9 times and did no math whatsoever, it would still be just as costly, or nearly as costly. You know what I mean? I mean, maybe I'm wrong, but like if I was to although this might actually get optimized because it'll realize I'm doing this. No, I guess it won't. Let's just see. Like if I just sample 9 times. 5, 6, 7, 8, 9. So let's try taking a capture. Oh, well, it does go down actually. Yeah, it's like almost half. In fact, it's better than that. Alright, so that's interesting. So basically, if I were to place these samples and into, can I do all with a matrix multiply? Possibly, right? Gotta think about this one. One thing I was curious about, and I was kind of messing around with this here, is you can actually get it's pretty cool. In RenderDoc you can see what the shader compiles down to, at least with different compiler views. Let me just see if I can get that here. Where is it again? Pipeline, FS, shader 82. And you go view. Yeah, so this is the shader itself. And you can say disassembly. And I notice if you try these different ones, you see it was smart. Okay, it was smart enough to sample only once, yeah. Okay. So that's not really totally fair. That's sort of what I wanted to see. I wanted to see if it's just smart enough to say, hey, we're sampling the same thing. We'll just sample once and then do the adding for all the values. So I do need to kind of do something to make it sample different points. So let's say we do like even that's just fine right there. I have to say, one thing I find rather challenging with GPU programming is optimizing. It's figuring out where the costs really lie. Okay, so here we go. So you see the glow pass now, we're back at about 1500, which is pretty much exactly the same. So really the real cost isn't the math. It's not the transformation that will save us, right? It's the very fact that we're sampling nine pixels from or like 9 samples. Or fragments, I guess. So I guess, one potential optimization is just sample less pixels, right? Instead of a 9 tap filter, we can make it like 7. But like, it's so micro at this point, Curious actually what it would look like. Obviously it won't look as good. I admit it's kind of hard for me to tell the difference. Definitely getting higher frame rates. Alright, good night, Meshu. Thanks for hanging out, man. Well, I was thinking about it, right? Like, sampling 2 times less, two less samples, that's 2 out of 9. That's more than 20% savings. I think that's what we're seeing here. Instead of taking 1500, we're taking 1180. So, yeah, maybe not a bad idea. But I do wonder what the difference really is. Another thing, this is not quite right because now I'm not sampling as far out. What I would need to do is actually scale these values based on the number of samples I want to take. Kind of like no. There's more than that. There's also the distribution of weights that has to be rethought out. This is not as simple as that. I'm not going to do this. I'll think a little bit more on this. But yeah, there's like these costs here that I would like to shave down, and I'm just not sure how to go about it. I think ultimately what I need to do is think about just getting rid of some of these passes. If there's a way I can combine more. Like I can probably get rid of the combined vector and glow if I can figure out how to immediately render those with scale. It's because combined vector and glow takes two buffers, the vectors one and the glow one, and puts them together and scales it, and render to screen renders that one, and it renders the, it's like it renders this one and the overlay together. And I could probably do all three, maybe with one draw call, I'm not sure. And then there's these unfortunate draw and darken that I have to do. I was wondering if I could like figure out a way not to do it this way. I don't know. Could I do? Definitely doesn't seem worth trying to optimize. I have a to-do that's like create an index buffer for my drawing my vectors. Seems like it's not worth it given the time it takes to actually do these steps. So I'm not going to look at that. It's a bit of a shame though that I have to do two completely separate draw passes. The only difference is the thickness, but then, yeah, maybe I could do that in one to two different target textures. Can you? Oh no, I guess you can't really write to more than one texture. And I don't suppose that there's a lot of overhead switching shaders here. Because I could do like the two draw vector passes into two darkens one after another, and avoid the switching between draw, darken, which are really the same shaders. But I don't think that's going to make any difference. Let me see. Just for now, I'm gonna simplify this code just a bit so I can try this. Let's say we didn't have any blur. So now I'll do the 2 draw vector passes at the same time. Yeah, I don't think it's making any difference. Yeah, it looks about the same. Not too surprising. Let's see, the 2 draw vectors followed by the 2 darken texture passes, but that pretty much lines up with, yeah, same values. One thing I read about that could maybe help here is using bindless textures. It's possible that, or using like, maybe not bindless textures, but I forget what it's called, but you know, allocating the texture storage and then, would that even help? No, maybe not. I'm not sure. I'm gonna have to think about it. All right. So I'm not getting too far with this. So maybe I'll just switch gears for a bit. I mean, it's not bad or anything. Just wish that I had a little bit more performance out of this. One thing I've been thinking about is looking into kind of like setting up on GitHub maybe AppVeyor or something that would like build my master branch and produce binaries that could be like downloaded. In the past, I mean, I haven't really done that. In the past, what I've done is I've like built my own binaries and uploaded them and tagged my own versions. But I wonder if there's a way to like have like a nightly build, you know? I haven't really looked into that. Yeah, maybe using Travis. Is it Travis that I would use? Not Travis Scott. Wow, 10,000% free. That's cool. Oh, is this the one that doesn't support Windows? I think that's the one that doesn't support Windows. So is it AppVeyor for Windows? So Travis CI for Windows. If I could just type. Oh, maybe. activation. Why not use Vagrant? Okay. Is somebody like kind of investigating the options here? Okay, there it is. AppVeyor CI for Windows. Let me look up AppVeyor then. Okay, so this is also free for open source. This looks pretty promising. And when you push your changes, for every private project, AppVeyor will add a SSH public key to the clone. Start a new build. So it's got a deploy phase. And how does it deploy? Deployment. The fact that AppVeyor deployment requires build artifacts on input makes the deployment process predictable and repeatable. Okay, so it supports a whole bunch of ways. GitHub releases. Okay, so it does support GitHub releases, that's good. Hey, what's up, HSRU? What's environment? To the existing environment. Oh, I see, okay. Yeah, the only thing about this is I don't really feel like doing the whole tag thing. You know, I just kind of want to like have a just a latest build. You know. I guess I could do a kind of a pre-release thing. I don't know. What do people do for this kind of thing? So what you been up to, HSRU? You need to code something for your portfolio, either PHP or Node.js, and I don't know what. Something that takes no more than 2 weeks to finish. MVP version of, less is good, and I don't feel motivated to make some generic shit like blocks. Right. So it's like totally open, you can do whatever you want? And it needs to be an MVP. Why don't you make a game? Can you make a game? Oh, okay, it's your own restriction. Okay. Okay, it's for potential employer. Why do you say it's not employee's request? Yeah, I don't know. I guess I see what you mean. In terms of, I guess it depends on what skills they're looking for, right? No worries, man, no worries. I can't type either. Yeah, I don't really have a lot of web experience, so it's hard for me to like come up with a great project. You know, I'll suggest writing a game or an emulator. But again, you know, like you say, maybe it's not what the skill that they're looking for, right? Have they given you some hints to what kind of skills they're looking for? Is it, you know, based on the job description? Do they want to see you interact with a database and, I don't know, do some fancy JavaScript stuff on the client side? CSS, all that stuff. I know somebody I know was taking a web course, and one of their assignments was to write like a web app. And what it would do is it would hook up to some, I think they were provided, but I think you could hook up to some existing online database for like weather information for different cities and places in the world. And the assignment was to like have the user select the city, and I think it would kind of like graph the temperature and the different things over time, and you could give it like a range and stuff like that. So it's just kind of like a data analysis thing for weather patterns in different places, and you could like overlay them and stuff. Or you can like compare the every year of weather for a given city for the last 10 years and show all those curves on one graph. Which, it's kind of somewhat interesting. Yeah, you could make a game. One stream that where somebody is making a game in JavaScript, which is really awesome. It's let's see if I can find it here. Just give me a sec. Sorry, I'm like off screen here. Yeah, it's here. It's Adam13531. It's like this one here. Have you heard about this? Oh yeah, you know it. Yeah. Anyway, for other viewers who don't, Adam13531 here, he's working on this cool game called Botland, and yeah, it's really awesome. So maybe I would just use FTP here. Just kind of upload them to some FTP I have, and the only other option really I'm thinking is going for the GitHub releases thing and kind of do a pre-release, have like a... Do you need to have a tag though for this to work? If not specified, build tag or optional. If not specified, build tag or version is used. That's it. If a current build is based on a regular commit, then a new tag is created. See, that's what I kind of want to avoid. Oh, skip tags. This means that unless you have a skip tag set to true, the creation of the tag will also send a webhook to AppVeyor, and the deployment process will begin again, and so on. To avoid this possible cycle, you can set skip tags to true. However, you may be using on key to conditionally build and deploy only on tags you create manually. In this case, you can specify tag. Yeah, so I think all of this is based on tags, though. Yeah, probably the simplest approach I can take is to just upload it to some space I have somewhere. Yeah. Okay, so I guess we would use application. Yeah, because I just think it would be cool to have like a running build of whatever's been committed, and I'd like to also have, you know, put like a part of the commit hash in there, maybe a running counter, I don't know, something like that, so that I could, you know, make it possible to download older versions, stuff like that. I don't know if that's useful. I don't know if it's useful to have these different versions or just have them on the latest. You know what, I'll be right back. I'm just gonna go to the washroom. Alright. Okay, so this is pretty cool. I think I'm gonna take a look at this off stream though, because I'm gonna have to like create accounts and put passwords and stuff. But yeah, I think I'm gonna try and set this up so, you know, if you guys who are watching are on Windows and, you know, don't feel like syncing the code and building and all that, you'll be able to at least test the latest version of my emulator. Hopefully sooner rather than later. The other thing that's going to be cool is there's all these things I want to try. So the big things I want to work on, I want to get this done. I would like to get a Linux build going. For that, I'm thinking about how to stream it. There seems to be like kind of two options. One of them is, of course, I could install you know, a VM in VirtualBox and basically just run it here. And that would probably be fine for just getting something compiling at least. But obviously running it's going to run like super slow. The only way really I can think of getting it to run quickly is to be natively working in Linux. No, I don't really have one, but I could totally install one on one of my hard drives. But then it's like setting up OBS and everything and my whole environment. I'd have to look into that. Alternatively, I'm wondering about it's something I haven't really played with, but you know, on Windows 10 you can install, what's it called again? It's the Windows subsystem, the Linux subsystem for Windows. And I don't know if the subsystem can actually run, like, if I have access to graphics cards and to running an SDL thing, you know? I'm not quite sure what this provides. Running graphical programs. Okay, so Microsoft doesn't support graphical programs on WSL. Bash on WSL is intended for running command line programs that developers might need, but it's possible to run a graphical Linux desktop programs on Windows using the Bash shell. To be more precise, you'll be able to display graphical programs running in WSL on a Windows 10 desktop by using an X server, which runs on Windows 10. Okay. But like, what does that mean? How graphical are we talking here? Yeah, it's only these like X11 based apps, right? Firefox worked even though I received some error messages on the command line. Blockout worked flawlessly, which surprised me as it is extremely graphics intensive. Yeah, I don't think this is going to be the solution, unfortunately. So probably I'll start off with a VirtualBox Ubuntu, like fresh Ubuntu install, and we'll see. It is possible, I think, to get it to be to access the graphics card and to render fast enough to at least see that it works. So I think that I can stream using VirtualBox. And then as for running it natively, well, I'll probably just test that on my own just to make sure that it's okay. I don't think I can show that easily on stream. I mean, we'll see. We'll see if I can set up OBS and stuff, but you know, I've got like my environment and stuff, so we'll see. All right, well, why is this like such a large font here? I guess you kind of notice I'm a little meandering a little bit here. I'm not quite sure what I want to work on next, that's why. Oh yeah, this is done. This is the thing I said I was gonna do. Yeah, see, I did this and it didn't actually speed up anything. Maybe I'll do this. I've kind of been wanting to do this for a while. I want to get rid of libpng and its dependency zlib because I hate it. And there's stb image on GitHub here, which is like a single header file that is so much easier apparently to use. So maybe we could take a look at that. If I go into, I think I'd already checked this for VC package. Let me see. I may already have the VC package for STB. Let me take a look. So something like VC package, I think there's a VC package search, right? VC package search STB. STB single file public domain libraries. Yeah, so this is it. So now we want to do install, and I just want to see, I guess it won't really matter which version we install, right? Because there's no libs. Yeah, see, it says it's already installed, and I think even if I had put 86 here, it would have made no difference, because they're all the same. So this is installed. Let's go take a look at what this actually looks like. Oh, there actually is R2 folders. Interesting. Or maybe it just was super fast. Public domain. So there's the include, and it would be, I guess, STB image. All right, so let's see what it would take to make this work. We go into our CMake lists. Sorry. So we say we don't need PNG anymore. No? Instead, we'll say find package. Actually, what do I have to write? Oh yeah, I'm gonna need to put some kind of find package for this thing. Let's see if I can find one. Find STB. .cmake. Yeah, some people do the include directories thing, which kind of sucks. Basically, I want one of these finds. I don't imagine CMake already has one. Yeah, it doesn't. It's got find SDL, but it does not have find STB. Maybe this. STBI. STB image. Okay, so this is specifically for STB image. The new BSD license. What's the new BSD license? Yeah, maybe I'll write my own. Why is this one called STB CMake anyway? It's been forked as STB CMake from Nothing's STB. Oh, you have the CMake folder. I just wanted to make it possible to I don't know. I mean, alternatively, I could just copy the header file. It is sort of the point of a header-only library, isn't it? But I would rather do this properly with dependencies. Let's do this. That is not what I meant to do. So let's say imgui underscore shall become stb. Nope. stb underscore. Okay, so STB include path. We are looking for include stb.h. So I guess just stb.h. Path suffixes. And there is no library, so we will forget about that. If stb include path, we set it to be found. All right, let's see if this works. So, what we want to do is we want to do the CMake here with the same toolchain file. So this toolchain file should, okay, source directory, not appear to contain, oh yeah, I'm in the wrong place. Vectrexy, build x64. Manually specified variable were not used by the project CMake toolchain file. Right, I think I need to delete the CMake cache for this to work. This is the exciting world of C++ dependency management. Today I was watching Ferris's video that he put out. It's a video of a presentation he gave at Fuse, and it's all about Rust and his experience with Rust. And he was talking about, you know, how Rust has what's it called again? Their whole build environment, cargo, that's it, and how like sweet it is, how nice cargo is to use, and you know, every time I have to do this kind of stuff with CMake files and manually like write these kinds of scripts and stuff, I think about how I wish we had something like that for C++. And I know I'm not the only one, but yeah, it's really quite annoying. Okay, so let's see here. Found SDL. Okay, GLM. So what happened to my? Did I not make those changes for STB? Or maybe I didn't. I guess we could do it here. Wait. Oh, I had not saved. Okay. Alright, that's okay. I guess we can reload, forget saving that. We'll just do it properly now and see if that works. So let's say we take off PNG and we say find package STB required. Let's start with that. Yeah, I think that did not work because I have to once again. I don't know what the right thing is, you know, in terms of iterating on this. I should always delete the CMake cache when I change dependencies. There might be a simpler way. Because this step is really long. detecting the compiler and all that. So it's not listing STB. Found glue, found. Is it just because we don't say it? Oh. But all the other ones say found. This one here says external library. And this one came from where again? We copied, I know I picked the smallest one. SDLnet? No. Find imgui. Let's see imgui. Oh yeah, and it doesn't actually output anything from imgui. The other ones say found. Let's see. Found GLM. Okay, so it doesn't actually come from here, the fact that it found it. It comes from CMake. Okay, it looks like it has something to do with this star found variable. Find package handle standard args. Find package handle standard args. But we have a found variable here. Why not? Let's install CMake support for VS Code. At least we'll get some highlighting. There we go. That's nice. So, I mean, we didn't get a message. Let's see if we put back this message, if it'll actually show anything. I guess now it's too late. Oh, there we go. External library STB found. So it is finding it. Oops, and then I deleted the cache. Great. Oh, so we have to wait for that again. All right, let's continue with our CMake list. So now that we have that, the next step is to add that to our include path. So PNG, yeah, we don't want the PNG includers, nor its definitions. Really all we want is the STB include path. Don't need libraries, don't need definitions. Alright, so let's see if that worked. Reload our solution. And we should see Oh yeah. Okay, so it's been all copied into here. So there's STB image and all that. So there's no like namespacing folder for STB. I guess that's just the way it's been designed. But too bad. Would have been nice if they had namespaced it. But it's alright. So this means that we should be able to include it. So right now the only place where I was doing stuff with PNG is in here. And basically this is where I want to get rid of this code that I find just absolutely awful. Make sure we build. I'll just remove all dependency on PNG here. Ah, yes. Okay, this should build and link. Now we should actually have no longer an overlay, which means probably it'll just look completely wrong. Oh, there we go. So no overlay. So that's good. So let's see. If we include STB image, and we need to also do this define STB image thing before you include this file, right? Yeah. So I guess we'll do that separately. Oh, that's kind of neat. So you can actually define a bunch of flags and say, I just want one of these. Or here you can say define only PNG, which is like, that could kind of be interesting. Right, okay, so if you want zlib. And then how do we use this? I guess it's this one right here. Got load from memory, load from callbacks, load from file. Probably just STBI load is what we want. What would X and Y be? Channels and file, yes. I guess the width and the height. What about whether it has alpha? Channels and file would tell us that. Okay. So let's see. Let's pass it a name. And let's do this. These are type int. Yeah, that's perfect. height. Now, number of channels in file. So here we'll say int channels. And then here it's desired channels. I guess I want to pass 3. I don't know. What does it do with this? Okay, process data if not null, x is width, y is height, n is 8-bit components per pixel. The 8-bit components per pixel. How many 8-bit components per pixel? Okay, so we have 1, 2, 3, or 4. So if it's 4, we'll have alpha. Otherwise, we expect 3. Replace 0 with a 1 to 4 to force that many components per pixel. Ah, okay. So we'll just put 0. And we'll set the result dot has alpha to whether num channels is equal to 4. Return results. Actually, you know what? I think I would prefer the code this way. And has alpha. Oh, and yes, I forgot. Even most importantly, is the result here is a stb UC buffer. So it's like a unsigned char buffer. Which we need to pass in as the last value. Oh, because of the unique pointer. Right. Okay, I need to so is this one of those things where the data that's returned, you're supposed to free it with its own function? Okay, yeah. Probably have to use stbi free. Let's see. Yeah, there it is. stbi image free. Trying to think how I want to do this. There's like kind of two approaches where we could allocate and move the memory in there, or we can just take ownership and create something that would create a type here that has a deleter, but then I kind of exposed the deleter over here, which kind of sucks. The deleter would actually end up, unless I type erase it. I would have to use shared pointer if I want to erase that type. Okay, let's say for now we just keep it simple. So we say like make unique visualizing. How do you make a unique array? What was I doing before? Let's see here. Oh, that's what I was doing. And then I was doing a mem copy. There we go. So okay, it won't be too different here. Still wonder, is there a way? Make unique array. Okay. So it's width times height times number of channels to get the byte size here, I suppose. Here we move the data into there, I think. Is that right? Why does it keep saying cannot convert from initializer list? Doesn't it see that this is an aggregate initialization? Too many initializer values. Oh, it doesn't have a num channels, okay. Okay, so I'm getting some warnings, which I think we're gonna have to just disable here. BPC, and so 4100 and 4505. Cool. So let's see if this actually works. I'll switch to debug just to see what's happening the first time. Okay, so here's our Mindstorm overlay. Oh, we got a buffer, we've got 465, 589, 4 channels, that looks good. So that should be whatever many bytes here. We allocate, we copy, we free, move the data into here. So this image data says it has alpha and it's got a unique pointer that says 0. Is that right? It does not look right. Oh no, it's fine. It's just the beginning of the buffer, but it does have a proper buffer. So let's see if this works. Oh, okay. Oh yeah, and it's flipped upside down. I think there was something about that. I think I actually had done something to flip it myself when I had written this code here. Note that PNG is ordered top to bottom, but OpenGL expects it bottom to top. So the order is swapped. Ah, that's why I'd written this kind of loop over its height. Yeah, okay. I wonder if STBI has any kind of option for that. That would be kind of neat. Let's see. Flip. STBI vertically flip on load. Interesting. So you can actually set this flag. Yeah, I'm not surprised that it would have that kind of ability. So let's see. So I want to know if I had a get for that, so we could like kind of push pop it, but it doesn't really matter. So let's see if this works. That did not do anything. Unless it was, is there like another one? Let me see. Yeah, I mean, it should be that. Flip the image vertically so the first pixel in the output array is the bottom left. Did I miss this? Oh, yeah. Probably a good idea to put that before we load. Not before we free. Okay, there we go. Alright, so let's do a couple of quick tests, but I think we should be in good shape here. Definitely much simpler, this code, probably more robust, probably faster, definitely very fast to build. So let's see, let's go try, well, let's just hit F5 here, just make sure this works again. So basically we're looking at the overlay here. The overlay is the one thing that we load using PNG. They're all PNG files. Looks good. So here are the overlays. All of them are PNG. So basically, Ripoff has one. That looks good. See, the alpha blending is working too, so that's fine. Cool. Okay, pretty cool. So now we can finally get rid of all this code with the set jump and all that. All right, so we've got our fine STB. And the only thing I need to do now is to update my README file before I do anything here. Let's see. So we'll remove libpng and we'll put stb here. I think that's it. Yeah, that's it. All right, replace, remove libpng and replace with stb image. All right, so I think I'm going to stop here. So thanks everyone for watching, and I should be streaming again in a couple nights, so see you then. Thanks again.